Hello everyone, I am Karan Mashru. Welcome to this video. In this video, we are going to look at the solution of the problem of the day, that is reverse alternate nodes in linked list. First of all, let us start by understanding the question. So what does question say? Given a linked list, you have to perform the following task. First, extract the alternate nodes starting from the second node. So second node, fourth node, sixth nodes and so on. So that those are the alternate nodes. Reverse the extracted list. So the extracted nodes which were at second position, fourth position, sixth position and so on, we need to reverse the linked list formed by them and append the extracted list at the end of the original list. Okay, so let us see one example, it will be more clear. Try to solve the problem without using any extra memory. So we need to do it in expected auxiliary spaces constant. Okay, so let's suppose our given linked list is 10, 4, 9, 1, 3, 5, 9, 4. Now what are the alternate nodes starting from second position? 4, 1, 5 and 4. So we need to extract them. Now we need to reverse their order. So 4, 1, 5, 4. Their reverse order would be 4, 5, 1, 4. And this extracted list would be appended at the end. So first of all 10, 9, 3, 9 which were not extracted from the list, that is 10, 9, 3, 9 will remain as it is. And 4, 5, 1, 4 will come here in reverse order, right? It was 4, 1, 5, 4. In the answer, it will be appended as 4, 5, 1, 4. So 4, 5, 1, 4. So this is the new linked list. Alternate nodes in the given linked list are 4, 1, 5, 4. Reversing the alternate nodes from the given list and then appending them at the end of the linked list results in 10, 9, 3, 9, 4, 5, 1, 4. If we look at the second example, it is 1, 2, 3, 4 and 5. So 2 and 4 are the alternate nodes starting from second position. So we will extract them. So the remaining is 1, 3 and 5. So 1, 3 and 5. Now 2 and 4 are extracted. Now we will reverse them. So it will become 4 and 2 and we will append it at the end of the linked list. So 4 and 2 will be appended at the end. So 1, 3, 5, 4 and 2. Okay. You don't have to read input or print anything. Your task is to complete the function rearrange, which takes the head of the linked list as input and rearranges the list as required, right? So basically we are given the head pointer to the linked list and we need to modify the linked list as per the requirement. Okay, the expected time complexity is big O of n and expected auxiliary space is constant and the constraints are given here. So suppose this is the given linked list in the input. So what we are saying is, first of all, extract alternate nodes starting from the second position. So this is the second position, this is the fourth position and this is the sixth position. So extract them. So the remaining linked list would be 1, 3, 5 and 7, right? Now the extracted list is what? Extracted list is 2, 4 and 6. Now we need to reverse the elements of this list. Okay, so it will become 6, 4 and 2 and we want to append this reversed linked list which contains the elements which were extracted from this starting from second position and alternate nodes were selected. We need to append this list at the end of this list. Okay, the elements which were remaining after we extracted these elements. So our final linked list will become 1, 3, 5, 7, 6, 4, 2 and this will become null. Okay, and this will be my head. Okay, head position. So this should be my answer. Okay, so I want to modify this linked list into this. Okay, so starting from second node, pick up the alternate nodes and extract them. So 2, 4 and 6 will be extracted. Remaining linked list will be this. 2, 4 and 6 will form this linked list. Now reverse it, so it will become 6, 4 and 2. Now append this reverse linked list at the end of this remaining list. So it will become 1, 3, 5, 7 which were the remaining elements after extraction and 6, 4, 2 will be appended in reverse order. So this will be my answer. So now how can we solve this? So basically what we can do is, see, this is the initial configuration of the linked list. This is my head 1 pointer. Let's call it head 1, which is pointing towards the which is the head of the original linked list. Now what I am thinking is, what I can do is I can traverse at alternate odd number of nodes. Okay, so this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. Okay, so what I'll do, I'll take one more pointer, head 2, which will initially be equal to null. Now in head 2 I want a linked list of the extracted nodes. So what I will do, I will traverse in linked list 1 at position 1, position 3, position 5 and position 7 and I will take the next node of this node. So if I am at one position, I will take this second node and will add in this linked list. Then when I am at third position, I will take fourth node and push in this linked list. Then when I will be at fifth node, I will take this node and will add in this linked list. Okay, so basically this linked list will be remaining with 1 3 5 7, and this linked list will have 2 4 and 6. So how can I do that? So what I will do is I'll take one temporary pointer t1, okay, to traverse the first linked list, because I do not want to change the head pointer. Now I can say head 2 is equals to t1 next. Okay, so basically this my head pointer will start pointing here because this is t1, right? And I will say t1 next is equals to t1 next. Okay, so what will this basically do is, see, this is t1 next is this pointer which is pointing towards 2, t1 next is this pointer, okay, which is pointing towards the node with number 3. So I am saying t1 next means this pointer is equal to t1 next, it should be equal to this pointer. So basically what will happen is this will go away and this will now be equal to this, it will start pointing here. So basically I wanted to extract 2 4 and 6, and I wanted to connect 1 3 5 and 7. So I have connected 1 with 3 and I have extracted 2 and add it in the second linked list. Now what I can do, as I have taken t1 to traverse the first linked list, I can take a pointer t2 to travel this extracted linked list. So I can take one pointer t2. Okay, now I can say t1 is equals to t1 next. Okay, so basically my t1 which is pointing here is equal to t1 next. T1 next is this, the node number 3. So t1 which is pointing here will now be removed from here, and t1 will start pointing here. Okay, now we will keep repeating this process until we reach the end of the linked list. So again, now what I can say, now I will not use head 2. I have used head 2 only first time because it was null. Now I will use t2. So I can say t2 next is equals to t1 next. Okay, so what will this basically do? t2 next means this pointer, t2 is pointing to this, t2 next means pointer which is pointing to 3 is equals to t1 next. T1 is this pointing to 3 and t1 next is this. So basically what they are saying is remove this pointer and make it equal to this. Okay, so now head 2 is connected to 2, 2 is connected to 4. Okay, now again I can say t1 next is equals to t1 next. Okay, as I have said here, to traverse the first linked list in further direction. Now t1 was here, this is t1 next, this should be equal to t1 next means it should be equal to this. So what will basically happen, this will go away, and what will happen, so basically this was t1, right? So t1 next means this pointer is equals to this pointer, t1 next. Okay, and again I will say t1 is equals to t1 next to go to the next node. Okay, so t1 is equals to t1 next. So t1 will come away from here and it will come to now t1 will be pointing to this. Okay, and I can also say t2 is equals to t2 next. Okay, so basically t2 which is pointing to 2, now it will go away from here and it will start pointing to 4. Okay, so can you see we have connected 1 with 3 and 3 with 5, and head 2 has connected to 2 and 2 is connected to 4. So we have extracted 2 and 4 from it. Now repeat this process. So t2 next is equals to t1 next. This is t2, this is t2 next, this is t1, this is t1 next. So this should be equal to this. So basically this will come out and this should be equal to this, right? Now t1 next is equals to t1 next. So this is t1, this is t1 next, this should be equal to this is t1 next. So basically this should be equal to this. Okay, it should point here. Now t1 is equals to t1 next, so t1 will go to the next pointer, so t1 will now be pointing here. Okay, and t2 is equals to t2 next, so t2 which was initially pointing here will now point to this was t2, this was t2 next, so it will point to this, right? Now again t2 next is equal to t1 next, but t1 next is empty, right? So we will not do anything. So if we observe this, what we have got, we have got head 1 here, we have got 1 is connected with 3, then 3 is connected with 5 is connected with 7. Okay, because now there was no next element, so we will stop the process there, and this will be equal to null, right? And if we look at head 2, so what will be the head 2? Here it is 2, head 2 is connected to 2, 2 is connected to 4, and 4 is connected to 6. Okay, so 2 is connected to 4 and 4 is connected to 6, and since this was the last element, we will make this equal to null. So we have extracted 2, 4 and 6 by doing this process, right? Now we want to reverse this linked list. So how can we reverse a linked list? We can reverse a linked list using 3 pointers. So basically I want to reverse this linked list. Okay, so basically reversing a linked list, what we can do is, see, this is 2, this is 4, and this is 6, right? And this is equal to null. So basically what we do is, initially we take previous, we take 3 pointers, previous which will be initially equal to null, current which will be pointing to 2, and next which will be pointing to current next. So this is next, okay, and previous will be initially null. Okay, so now we have taken this starting node as the current node, which will nothing be equal, but it will be equal to head 2. So current will be equal to head 2 and previous will be equal to null, because there is no node before this. Now we will repeat 4 steps again and again until current does not become equal to null. So what we will do is, first of all we will say next is equals to current next. Okay, so basically this was assigned to current, so next will be assigned to 4. Okay, then I will say current next is equals to previous. Now understand one thing, current next, it means this pointer is equal to previous. Previous is how much? Null. So basically this pointer will now be pointing to null. Okay, so this will now point to null. Okay, and then what I can say is, I can say previous is equals to current. So now previous node which was equal to null will now point to this, and current is equals to next. Okay, so now current pointer which was pointing to this will now point to the next node. What is next? Next is 4. So now current will point to this, and we will repeat this process until current does not become equal to null. So next is equal to current next. Now current is this, so what will be next? Current is pointing to 4, so next will be pointing to 6. Now current next is equals to previous. Current is 4th node, current next is this one, and previous is this one, pointer pointing to node 2. So what it basically says is, current next means the pointer which is coming out of from 4 should point to previous, so it should point to 2. Okay, so now this node will point to 2, and previous is equals to current. So now previous will become this one. Okay, so this will become previous, it is equal to current, and current equal to next. So this will become equal to current. Okay, now again this will be repeated, next is equals to current next. So current next is null, so my next will become null, right? So it will become null. Then current next equals to previous. This is current next, this is current next, it is equal to previous. Previous is the node pointing to 4, so this will basically now start pointing to this. Previous is equals to current, so previous will come to here, pointing to node number 6, and current will become next, and next is null, so current will become null. Okay, and we will stop the process here. So basically, can you see, from 6 we are coming to 4, and from 4 we are coming to 2. Now previous is pointing to 6 when we are coming out of the loop, so I can say head 2 is equals to previous, right? Because this will be my new head, so the head pointer which was pointing to here will now go away and will now start pointing to this. Okay, so head 2. So what it basically means is, head 2 is pointing to 6, from 6 we are going to 4, from 4 we are going to 2, and from 2 we are coming out of null. So basically the linked list which was 2 4 6, it has been reversed and it has become 6 4 2. Now we have to do nothing, we have to traverse this linked list and come till this pointer. Okay, the last pointer, let's say it is T1, and then I will say T1 next is equals to head 2. So basically T1 next is this pointer, so now it was equal to null, right? So it will become equal to head 2. So this will point to head 2, which is nothing but this. So my linked list will become 1 3 5 7 6 4 and 2, which we required. So basically, just to conclude, what we will do is, using T1 T2 head 1 and head 2, I will traverse to all through the odd number of nodes. So 1 3 through 1 3 5 and 7, and I will add second node, fourth node and sixth node as shown here to the second linked list. So we will get 2 linked list, 1 3 5 7 and 2 4 6. Then we will reverse this linked list using this concept, and this would be the head pointer which we will append here. So we will get 1357642 and our task will be done. Now let's look at its actual code. So now if we look at the actual code, so what I have done is, see, this is the odd, which is the pointer to the head of the linked list. So first of all, if odd next is equals to null, it means if there is only one element, then there is no point of reversing the alternate node starting from second position. So we will directly return. Otherwise, head 1 is equals to odd, so it is the head pointer to the original linked list, and head 2 is equals to null, as I explained in the concept. So in head 2, we will add the linked list of the extracted nodes. Okay, I will take two temporary nodes, T1 and T2, to traverse the original linked list and the extracted linked list, because we do not want the head pointers to be changed. Okay, so we will use T1 and T2 to traverse. So we will say T1 is equals to head 1. Now while T1 is not equal to null and T1 next is not equal to null, we will repeat this process. Now why I have taken here two things? Because if you remember, T1 is basically traversing the nodes at odd position 1, 3, 5, 7 and so on. Okay, so when will we end the process? In case the it will depend whether the number of elements in the linked list is odd or even. So either this case or this case will occur. So I have taken two cases, either there is no next element or that same element is null. So okay, so in both of that cases we will be finishing the while loop. Okay, so if head 2 is equals to null, so if this is the first element in the extracted linked list, then head 2 is equals to T1 next, because T1 is pointing to the element in odd positions. So T1 next will be element in the even positions. So we will push it in the second linked list, and we will take T2 is equals to head 2 to traverse in further iterations. Else if head 2 is not null, it means there is some element in the second linked list. Then T2 next, it means T2 will be at the last position of the second linked list, right? So T2 next is equals to T1 next, and T2 is equals to T2 next. Okay, T2 will always point at the last element of the extracted linked list. Okay, and then T1 next is equals to T1 next. We will skip one element and go to the another odd element, and then T1 is equals to T1 next. Okay, so in this way basically we will traverse the odd position nodes using T1 and extract even position nodes and add it in the list number 2, which is pointed by head 2. Then we will make T2 next is equals to null, because that is the last element of the second linked list. So after that we need to make the last if it is at the end position, then the next pointer should be null. Okay, and then I will say reverse the second linked list, which is pointed by head 2, and I'll call the reverse function. Now let's look at this reverse function. So if we look at the reverse function, so basically as I told, we are doing nothing but taking previous as null and current as a head and one next pointer. Okay, and while current is not equal to null, next is equals to current next is equals to previous equal to current, and current equal to next. How this works I have shown you in the example. Okay, it will basically reverse the linked list, and after coming out of the while loop I'll say head is equals to previous, because the last element will now become the head, because the linked list has been reversed. So after this function is done, also remember I have passed the head pointer as a reference. Okay, so I want that head pointer only to change. I have not passed this as value. So this will basically reverse the extracted linked list. Now if we look, what I have done here is, after reversing this linked list, I have taken T1 equals to head 1, because now I want to append the reverse linked list at the end of the remaining linked list. Okay, the original linked list which was pointed by head 1. So I need to reach at the end of the first linked list. So I started traversing it. So I have taken T1 equals to head 1, and while T1 next is not equals to null, T1 is equals to T1 next. So when this will end, when T1 next will be equal to null, means the next pointer of the current node will be null, and that is true only for the last node. Okay, so T1 after coming out of the while loop will be pointing to the last node of the first linked list, and T1 next means the next pointer of the last node is equals to head 2. Head 2 is the pointer to the reverse linked list of the extracted element, so that linked list will also be appended. Okay, if we talk about the time complexity, what would be the time complexity? See, extracting the nodes at even positions and combining them in a linked list and combining the elements at odd positions basically required one for loop. Okay, so it will take big O of n time, and reversing the linked list of the extracted node which has n by 2 elements will also take n by 2 size. Okay, so this will nothing but equal to big O of n only. Okay, and what would be the auxiliary space? The auxiliary space required will be equal to constant, because we have not used any new variables here. Now let's submit this code. So let's submit it. So we have solved this question successfully. I hope you have understood the solution completely. Thank you.